Hello once again. We have just one more section for this chapter, one more section for this unit, so let's get to it. We have gone through all of the essentials to making a good hypothesis test. We have done it in particular for proportions. We've got deep into the paint for it for means. Let's also get into the thick of it for variance and standard deviations. Now here, I'll go ahead and tell you, we are going to rely more and more on technology to help us out here. That is because, yes, you can do z-tables pretty reliably to define p-values and that sort of thing for the z distribution, the normal distribution. For t-tables and t-distributions, same thing. You can kind of do it. You'll probably want technology there. Now we're getting into chi-squared distributions and chi-squared tables, and the water gets ever murkier, harder to follow through the deeper into it we go. That said, though, the process is unchanged. We're still going to start with our claim. We're going to use that claim to make our testable hypotheses, first with the status quo, the null hypothesis, and with the alternate hypothesis. We will decide on our significance level before we get too deep into it to avoid confirmation bias or negativity bias or just the fear of being wrong. We're going to get sample data. We're going to calculate test statistics. We'll still do that in this process. We'll generate p-values using technology. We'll decide to reject or fail to reject our null hypothesis, giving us something or perhaps not something to say about the original claim. So that whole process, start to finish, is unchanged. Really, the only thing that's changed for us from the end user perspective is what test statistic do I look for variance or standard deviation? Well, it's chi-squared. The formula to calculate chi-squared is on your screen right now. It involves your hypothesized variance here, which is also the square of standard deviation, your sample variance, which is also the square of your sample standard deviation, and the sample size, -1. So degrees of freedom if you want to be fancy. And that's all that's changed. This formula is all that's changed. The other thing that's changed, of course, since we're talking about chi-squared as your statistic, that puts us not on the normal distribution, not on the t distribution, but on the chi-squared distribution. So we'll have to use that table or the appropriate technology for the appropriate lookup. But that's all that's changed. So I will be a little briefer than I have been in the previous video series regarding these sorts of things. That said, though, I will go ahead and introduce to you in this video the claim and the sample data, and I want you to take a minute between now and when you watch the next video to come up with as much of the rest of this table as you can. The null hypotheses, the alternate hypotheses, and also the chi-squared values based on sample size, sample standard deviation, or sample variance, and hypothesized or claimed variance or claimed standard deviation. Our three claims read as thus. The standard deviation of all soda cans, I actually didn't put enough words in this sentence, the diameter of, or the thickness of the cans should be 0.06 inches. I got 30 cans. They had a standard deviation of 0.005. Next up, we have high risk if the standard deviation exceeds 4%. We want to test to see if a particular fund is at risk. So I looked for 24 months on the same fund, and their growth rate was, or the standard deviation was this thing right here. Finally, we've got 20 players, and we want to see if their standard deviation of height is equal to 2.5. So read over this on your own, come up with some hypotheses, and if you're feeling frisky, calculate the test statistics. And we'll reconvene in the next video, and we'll see if we're right.